Hello viewers, in this video lecture today we are going to talk about the massive open online course on emerging technologies in renewable energy sources. The name of the subject domain is biomass energy, and today we are going to discuss maintenance of biogas plant. So viewers, here are the important topics which will be discussed in this video. The first one is what is biogas, how is biogas produced, biogas plant, biogas production steps, how to maintain biogas production, fuel properties and application and advantage and disadvantages. So introduction, the biogas industry has started flourishing and will play an important role in the energy mix of India's renewable energy portfolio. We proudly want to say that we have succeeded with different phases to ensure the sustainable growth of the biogas industry for the past 8 years, and we hope to continue doing that for years to come and make our family bigger and make biogas industry a front runner of the renewable energy sector. Biogas is produced when biodegradable organic materials, waste such as cattle dung, biomass from farms, gardens, kitchens, industry, poultry droppings, night soil and municipal waste are subjected to a scientific process called anaerobic digestion in a biogas plant. Biogas plant design depends upon several factors, and the feedstock to be processed is of paramount importance. Biogas is a mixture of gases, primarily methane, that is CH4, and carbon dioxide, that is CO2, and traces of hydrogen sulfide, that is H2S. Other than this, moisture produced by the decomposition breakdowns of biodegradable organic matter in the absence of oxygen from raw materials such as agriculture waste, cattle dung, poultry droppings, municipal waste, plant materials, sewage green waste or food kitchen waste. Biogas has a calorific value of about 5000 kilocalorie per meter cube. The digested slurry produced from biogas plant as a byproduct is a better source of nutrient enriched organic manure for use in agriculture. Not only helps in improving the crop yield but also maintains soil health. There is ample potential of setting up biogas plant considering the livestock population of 512 millions, which includes about 300 millions total population of bovines comprising of cattle, buffalo, methane and yak. The livestock sector contributes about significantly to India's GDP and will continue to increase. The dissemination of biogas technology is a boom for Indian farmers with the direct and collateral benefits. Biogas is a mixture of methane and small quantities of other gases produced by anaerobic digestion of organic matter in an oxygen-free environment. The precise composition of biogas depends on the type of feedstock and the production pathway. These include the following main technologies: biodigester. In the biodigester, these are airtight systems, example container or tanks, in which organic material diluted in water is broken down by naturally occurring microorganism. The contaminants and moistures are usually removed prior to use of biogas. The landfills, gas recovery systems, the discomposable of municipal solid waste, that is called MSW, under anaerobic condition at landfills sites produces biogas. This can be captured using pipes and extraction wells along with compressors to include flow to a central collection point. Wastewater treatment plants. These plants can be equipped to recover organic matter, solids and nutrients such as nitrogen and phosphorus from sewage sludge. With further treatment, the sewage sludge can be used as an input to produce biogas in an anaerobic digester. The methane content of biogas typically ranges from 45% to 75% by volume, with most of the remainder being CO2. This variation means that the energy content of biogas can vary. The lower heating value is 16 megajoule per meter cube and 28 megajoule per meter cube. Biogas can be used directly to produce electricity and heat or as an energy source for cooking. Biomethane, also known as renewable natural gas, is a near pure source of methane produced either by upgrading biogas and a process that removes any CO2 by other contaminants present in the biogas, or we can say it can through the gasification of solid biomass followed by methanation. So, upgrading biomass or biogas, this accounts for around 90% of the total biomethane produced worldwide today. Upgrading technologies make use of the different properties of the various gases contained within the biogas to separate them, with water scrubbing and membrane separation accounting for almost 60% of biomethane production globally today. The thermal gasification of solid biomass followed by methanation woody biomass is first broken down at high temperature between 700 to 800 degrees Celsius and high pressure in a low oxygen environment. Under these conditions, the biomass is converted into a mixture of gases, mainly carbon monoxide, hydrogen and methane, to produce a pure steam of biomethane. This syngas is cleaned to remove any acidic and corrosive components. The methanation process then uses a catalyst to promote a reaction between the hydrogen and carbon monoxide or CO2 to produce methane. Any remaining CO2 or water is removed at the end of this process. Biomethane has an LHV low heating value of around 36 megajoule per meter cube. It is identical from natural gas and so can be used without the need for any changes in transmission and distribution infrastructure or end user equipment, and is fully compatible for use in natural gas vehicles. Now we are moving on biogas consumption and installed capacity. So, the global direct consumption of biogas was around 35 million tons of oil equivalent in 2018. Currently, over 60% of biogas production capacity lies in Europe and North America. As the leading biogas production region, Europe has around 20,000 biogas plants, with the majority situated in Germany. Most are built for an on-site electricity generation and co-generation, with around 500 plants dedicated to the upgrading of biogas 2019. In the steps projected for production of biogas for direct consumption more than doubles, reaching around 75 million tons of oil equivalent in 2040. Most of this growth comes from centralized plants that are fed by agricultural and municipal solid waste sources in order to meet local power and heating demand. The share of biogas used for power and heat rises from around 70% today to 85% by 2040. Providing a renewable and reliable source of power has typically been the easiest route to market for biogas, given incentives such as feed-in tariffs, subsidy grants and tax relief schemes that can also support the development of rural areas. The economic case for biogas improve when biodigesters are favorably located. Example, close to feedstock sources, electricity network and local heat offtake, or we can say where co-benefits like such as the ability of biogas plants to treat wastewater with high levels of organic pollutants are recognized and remunerated. Such co-benefits from biogas production can address a suite of sustainability priorities in developing economies, which are set to capture 3/4 of the growth in global biogas production. China, already producing almost a third of the global total, is seeking to expand rural biogas production to reduce air pollution from coal use while improving waste management practices, which plans to reach a level of nearly 17 million tons of oil equivalent by 2030 from around 7 million tons of oil equivalent today. India has offered to provide financial support to local biogas cogeneration plant and has overseen the deployment of more than 5 million household biogas units for clean cooking. The prospects for biogas are further galvanized by wider bioenergy targets in countries such as Indonesia, Malaysia and Thailand. These countries are seeking to develop a biogas market by leveraging vast quantities of available residue produced from certain industry sectors such as the palm oil industry. Biogas also provides an important option to support clean energy commitments at community level, especially where access to national electricity grids is more challenging or where there is a large requirements for heat that cannot be met by renewable electricity. There is also a considerable push to develop biogas for clean cooking. By 2030, around 200 million people move away from the traditional use of biomass through biogas, half of whom are in Africa. Biogas production in the SDS ultimately comes from thousands of local small scale facilities compared with the traditional large scale centralized infrastructure that meets most energy service demand today. While this has several co-benefits for rural communities, it also creates challenges for scaling up output as larger plants require more sophisticated to cooperative models and are also more exposed to the variability of different waste stream. It is also less carbon that biogas digester can undergo the type of factory style modular fabrication that has driven down the manufacturing cost of other renewable technologies such as solar PV. Biogas is produced by microorganisms such as methanogenous and sulfate reducing bacteria performing anaerobic respiration. Biogas can refer to gas produced naturally and industrially in soil. Methane is produced in anaerobic environments by methanogenous but is mostly consumed in anaerobic zones by metrophores. Methane emissions results when the balance various methogenous. Wetland soils are the main natural source of methane. Other sources include oceans, forest soils, termites and wind rumina. In industry point of view, the purpose of industrial biogas production is the collection of biomethane usually for fuel. Industrial biogas is produced either the first as landfill gas, that is LFG, which is produced by the decomposition of biodegradable waste inside a landfill due to chemical reaction and microbes, or the second as digested gas produced inside an anaerobic digester. That is, biogas plants are reliable source of decentralized renewable energy for heating, cooking as well as generating electricity, power generation and thermal energy application alternatives in our country. In order to promote this decentralized renewable energy source of power generation, specifically in the small capacity range, that is 3 kilowatt to 250 kilowatt, and thermal energy for heating, cooling from the biogas produced from biogas plant of 30 meter cube to 2500 meter cube size operated based on the availability of required quantity of biodegradable organic waste. The organic biodegradable waste from various sources such as cattle dung, animal waste, food and kitchen waste, poultry dropping waste, agro-industry waste, others also are the feedstock for biogas plant. These plants are especially beneficial for meeting of grid power requirements for individual dairy and poultry plants, dairy cooperative for operation of dairy equipment and other electrical, thermal and cooling energy requirements for plant operation. The installation of such biogas system replaced diesel in DG sets and also reduced the electricity bills of the individual farmers, beneficiary entrepreneurs, dairy farmers, dairy cooperative, thereby helping to increase the income of farmers and users. The nutrients enriched organic biomanure is another stream of incoming generation from biogas projects and the same time saving in the expenditure of chemical fertilizer by reduction of use of chemical fertilizer and other profitable venture like organic farming. Biogas in India has been traditionally based on dairy manure as feedstock, and these gobar gas plants has been operations for a long period of time, especially in rural India. The last 2-3 decades, research organization with a focus on a rural energy security have enhanced the design of this system, resulting in newer efficient low cost designs such as the Deen Bandhu model, The Deenbandhu model is a new biogas production model popular in India. Deenbandhu means friend of the helpless. The unit usually has a capacity of 2 to 3 cubic meters. It is constructed using bricks or by a forcement mixture. In India, the bricks model costs slightly more than the forcement model. However, India Ministry of New and Renewable Energy offers some subsidy per model constructed. Global market of biogas power plant is, the market size was USD 24 billions in 2020 and it's projected to grow from USD 25.61 billions in 2021 to USD 37.02 billions in 2028. It growing at a CAGR of 5.4% during the 2021 to 2028 forecast period. The global biogas market size was valued at USD 62.72 billions in 2022 and is projected to grow at a compound annual growth rate, that is our CAGR, of 4.3% from 2023 to 2030. The global biogas industry is expected to witness growth on account of the rising product demand for various applications such as electricity, heat, vehicle fuel, upgraded biogas and cooking gas. We can shifting focus towards the use of renewable energy, particularly in the electric power sector, have significantly driven and the demand for biogas in electricity applications. In addition, the increasing need to reduce dependency on fossil fuel is creating lucrative opportunities for biogas in vehicle fuel applications. The US is one of the largest market for biogas in North America in 2022 and is projected to grow at a significant growth rate in terms of value over the forecast period. The United States government has introduced several regulations to lessen its dependency on conventional fuels and meet the goal of zero carbon emission. Significant factors that are influencing market growth such as favorable regulatory and political support, environmental support and customer support. Other than this, geopolitical support, agricultural and economic support also are important point. So, the demand for biogas in North America is primarily driven by the US. The growing demand for the product in applications such as cooking gas, electricity, vehicle fuels, heat and others is expected to have a positive impact on the industry growth over the forecast period. Major factors supporting the growth of the market in the region include high demand for green fuels, stringent environmental regulations and increased investment for the development of refineries. The abrupt onset of the COVID-19 pandemic caused an industrial lockdown that brought all manufacturing activity to a grinding halt in most industries around the world. Hence, it has also impacted product demands in heat generation application. Sluggish industrial activities have reduced the demand for heat consumption, thereby negatively affecting the demand for biogas. Now moving on the source insights. So, the municipal source segment lead the market and accounted for 41.45% revenue share in 2022. The growing usage of this municipal solid waste is MSW in the production of biogas to reduce landfills and greenhouse gas emissions is expected to support the market demand over the forecast period. The industrial segment is expected to witness significant growth over the essential period. The growing interest in finding effective means to obtain bioproducts and biofuel from industrial food waste, coupled with an increasing need for wastewater treatment in the industrial sector, is expected to fuel the market demand over the forecast period. Now we are moving application insights. So, the electricity application segment lead the market and accounted for about 30% revenue share in 2022. The growing attention to the use of renewable energy, particularly in the electric power sector, has significantly increased the use of biogas for electricity generation. In 2019, approximately 220 million kilowatt hour of electricity was generated using biogas, and from industrial and sewage wastewater treatment facility approximate 1 billion kilowatt hour of electricity was produced. Biogas in the country qualifies as a renewable energy fuel to generate electricity as per the state renewable electricity standards, that is called RES. upgrade biogas application is expected to grow significantly over the forecast period owing to the rising demand for biofuel in various end-use industries including automotive, which is expected to fuel the market demand. Upgrade biogas is produced by converting biogas into biomethane by removing hydrogen sulfide, carbon dioxide, water and contaminants from the biogas. Now moving in the regional insight. Europe was the dominant regional segment in 2021 and accounted for about 41% of the revenue share in 2022. The Europe biogas industry is growing owing to technology developments and increasing investment in the region's refinery industry. Companies across Europe are investing huge capital in research and development of biogas production from existing resource and planning to increase the share of feedstock over the next few years. This will fuel the market growth of biogas across the region. In Italy, the market is driven by the efforts of the government to move towards decarbonization. For instance, in March 2021, Enispa agreed to buy an Italian biogas company from FRIEL, that is Green Power and a Grosneri family holding through its circular economy subsidiary, EcoFuel. The acquisition is yet to be approved by the relevant antitrust authorities. India's market of biogas power plant was valued at $1.4 billion in 2021. The market is expected to grow from $1.47 billion in 2022 to $2.25 billion in 2029 at a CAGR of 6.3% in 2022 to 2029 period. The potential of compressed biogas production from various sources in India is estimated at about 62 million tons per annum and also help bring down dependency on crude oil imports. India's biogas market is expected to grow from $1.47 billion in 2022 to $2.25 billion in 2029 at a CAGR of 6.3% in forecast period of 2022 to 2029. In India, Nepal, Pakistan and Bangladesh, biogas produced from the anaerobic digestion of manure in small scale digestion facilities is called gobar gas. It is estimated that such facility exists in over 2 million households in India, 50,000 in Bangladesh and thousands in Pakistan, particularly North Punjab due to the thriving population of livestock. The digester is an airtight circular pit made of concrete with a pipe connection. The manure is directed to the pit, usually straight from the cattle shed. The pit is filled with the required quantity of wastewater. The gas pipe is connected to the kitchen fireplace through control valves. The combustion of this biogas has very little odor or smoke. Owing to simplicity is implementation and use of cheap raw material in village is one of the most environmentally sound energy source for rural needs. One type of this system is the syntax digester. Some designs use vermiculite culture to further enhance the slurry produced by the biogas plant for use as compost. In Nepal, the government provides subsidies to build biogas plant at homes. Now moving on the what is biogas. So it is a renewable energy source produced by the breakdown of organic matter by certain bacteria under anaerobic condition. It is a mixture of methane, hydrogen and carbon dioxide. It can be produced by agricultural waste, food waste, animal dung, manure and sewage. This process of biogas production is also known as anaerobic digestion. Biogas recycle the waste production naturally and converts them into useful energy, and it preventing any pollution caused by the waste in the landfills and cutting down the effects of the toxic chemical released from the sewage treatment plants. Biogas converted the harmful methane gas produced during decomposition into less harmful carbon dioxide gas. The organic material decomposes only in a wet environment. The organic matter or the waste dissolves in water and forms a sludge which is rich in nutrients and used as a fertilizer. Biogas naturally occurring that is generated by the breakdown of organic matter by anaerobic bacteria and is used in energy production. Biogas differs from natural gas in that it is a renewable energy source produced biologically through anaerobic digestion rather than a fossil fuel produced by a geological process. It is primarily composed of methane gas, carbon dioxide and trace amount of nitrogen, hydrogen and carbon monoxide. It occurs naturally in compost heaps as swamp gas and as a result of enteric fermentation in cattle and other ruminants. Biogas can also be produced in anaerobic digestion from plants or animal waste or collected from landfills. It is burned to generate heat or used in combustion engines to produce electricity. Animal and plants wastes can be used to produce biogas. They are processed in anaerobic digester as a liquid or as a slurry mixed with water. Anaerobic digester are generally composed of a feedstock source holder, a digestion tank, a biogas recovery unit and heat exchangers to maintain the temperatures necessary for bacterial digestion. Small scale household digestions containing as little as 757 liters can be used of providing cooking fuel or electric lighting in rural homes. Millions of homes in less developed regions including China and part of America and estimated the use of household digester as a renewable energy sources. How this biogas produced? So, biogas is renewable fuels that produce when organic matter such as food or animal waste is broken down by microorganism in the absence of oxygen. This process is called anaerobic digestion. For this to take place, the waste material needs to be enclosed in an environment where there is no oxygen. Biogas can occur naturally or as a part of an industrial process to intentionally create it as a fuel. Biogas is produced through a process of various types of organic waste. It is a renewable energy and environment friendly fuel made from 100% of local feedstock that is suitable for a diversity of uses including road vehicle fuel and industrial uses. The circular economy impact of biogas produce is further enhanced by the organic nutrients recovered in the production process. It can be produced from a vast variety of raw materials. The biggest role in the biogas production process is played by microbes feeding on the biomass, and this digestion carried out by these microorganisms create methane which can be used as it locally or upgraded to biogas equivalent to naturally gas quantity, and it enabling the transport of the biogas over longer distance. Material containing organic nutrients is also produced in the process, and this can be utilized for purpose such as agriculture. The biogas production process known as anaerobic digestion, it is a recognized sustainable technique. It provides renewable methane from plant photosynthesis. In principle, the idea is to convert organic material created by sun's energy into renewable energy for use by mankind. It also recycles the nutrients such as nitrogen and phosphorus to sustain the process in future years. It is produced using well established technology in a process involving several stages. The first stage is bio-waste is crushed into smaller pieces and slurrified to prepare it for the anaerobic digestion process. Slurrifying means adding liquid to the bio-waste to make it easier to process. The second, microbes needs warm conditions, so the bio-waste is heated to around 37 degrees Celsius. The third, the actual biogas production takes place through anaerobic digestion in large tanks for about 3 weeks. In the final stage, the gas is purified, upgraded by removing impurities and carbon dioxide. After this, the biogas is ready for use by enterprises and consumers, for example in a liquefied form or following injection into the gas pipeline networks. The steps are hydroelectric fermentative. The hydrolysis stages is the first in the biogas production. It is the one that simplifies the obtaining of carbon to microorganism present in the biological consortium of the biological reactor. Making organic matter accessible to microorganism accelerate the process of obtaining biogas as well as its greater purity. The next step is acidogenesis. In the production of biogas, the next step of anaerobic digestion involves acidogenic bacteria. They break down the sugars, fatty acids and amino acids from the previous step into acids such as acetic acid, propionic and butyric acid, and alcohols ammonia, hydrogen, carbon dioxide and hydrogen sulfide. The next is acetogenic. It is the process whereby acetate, a derivative of acetic acid, is created by acetogenic organism from carbon and energy sources. During this stage, acetogenic microbes catabolize most breakdown products from acidogenesis into acetic acid, hydrogen and carbon dioxide. Acetogenic bacteria therefore digest the biomass to product that methogenic bacteria can utilize to create methane. The next step is methogenesis. In this step, obligate anaerobic methane producing bacteria produce methane gas as the major end product along with carbon dioxide, hydrogen and traces of other gases. Methogenesis has 6 major pathways, each covering a different substrate into methane gas. The 6 major substrates used are carbon dioxide, formic acid, acetic acid, methanol, methylenamine and dimethyl sulfate. The acetic acid produced in the previous stage is converted into methane and carbon dioxide by a group of microorganisms called methanogenesis. In other words, it is processed by production of methane by methanogens. They are obligatory, anaerobic and very sensitive to environment changes. Methogenes utilize the intermediate products of the preceding stage and convert them into methane, carbon dioxide and water. It is these components that make up the majority of the biogas emitted from the system. Let us understand the fuel properties of the biogas. It is a mixture of different components and the components varies depending upon the characteristics of feed material, amount of degradation and others also. Biogas predominantly consists of 50 to 70% methane, 30 to 40% carbon dioxide and low amount of other gases. Methane is a combustible gas. The energy content of biogas depends on the amount of methane it contains. Methane contents varies from about 50 to 70%. The composition and the properties of the biogas are given in the following terms. The application parts of this biogas. The first, biogas used as fuel used to generate electricity. Biogas is used to run any type of heat engine in order to generate electrical and mechanical power, producing high quality fertilizer, reducing water and air pollution. The next one is our disadvantage or advantage of biogas. So, first we are discussing advantage of biogas. Biogas is very advantageous, which we will study below. The first point, non-polluting, that is biogas burns without smoke, therefore it involves no harmful gas such as CO2, CO, NO2 and SO2. The second point, reduce landfills. The slurry which produces after the production of biogas, we can use it as manure in the fields. The techniques of disposal is safe and effective and henceforth no space gets wasted in the form of landfills. The third, inexpensive technology. A biogas plant does not require an expensive installation cost and becomes self-sufficient within a time span of 3 to 4 months. It creates employment. It also creates work opportunity for thousands of people, especially in rural areas. The next advantage is renewable source of energy. We consider it to be a renewable source of energy as the production depends on the production of waste, which is an endless process. And the last, we can discuss this disadvantages of biogas. In addition to having many advantages, there are also some disadvantages of biogas. The first, inefficient on a large scale, as it is difficult to boost the efficiency of biogas. It is not economically feasible to use biogas on a large scale. The second, it contains impurities. It comprises a lot of impurities which are difficult to control even after putting it through many rounds of purifications. When we compress biogas to use as fuel, it proves to be extremely corrosive to the container. The third, unstable and hazardous. When methane comes in contact with oxygen, it reacts violently to create carbon dioxide. As a result, the highly inflammable nature of methane makes it susceptible to explosions. Thank you so much for watching this video.